Right, let's start the discussion for the second paper in the test paper 4, right? Uh, today, in the first question, following is a diagram to show distribution of power to household circuit from a main power grid, right? So I think you have go through these questions, right? Then in the first part, categorize X, Y, Z shown in the diagram as step up and step down transformers, right? Okay, let's find out what are the difference between the step up transformer and step down transformer, right? Normally, uh, let's consider this kind of a soft iron metal, right? Normally, in a transformer, this is the simple circuit diagram. Right? In transformer consists of primary coil and secondary coil. Okay, this is the primary coil or the primary wire, and this is the secondary wire or secondary coil, right? Normally, now let's consider that now in the number of turns in the primary coils and the secondary coils are different, right? Normally, let's assume that we represent number of turns in the primary coil as NP and the number of turns in the secondary coil as NS, right? Normally, in a step up transformer, number of turns in the primary coil is lesser than number of turns in the secondary coil, right? In a step down transformer, NP is greater than NS, right? So this is the normal thing. So that's mean simply if I reveal the what is the meaning of step up and the step down transformers. So they in a step up transformer, what happened? The voltage is increased when it's come to the secondary coil. Now let's take an example. Let's assume that the voltage of the primary coil as NPP and the voltage or potential difference of the secondary coil as PS. Right here, in a step-up transformer, the voltage of the primary coil or the potential difference of the primary coil is lesser than the Vs. So likewise, in a step-down transformer, the potential difference in the primary coil is greater than the voltage difference, the potential difference or the voltage in the secondary coil, right? So this is the simple uh, things that you need to know regarding the step up and the step down transformers, right? So if I reveal some important, there are some two equation which is revealed with the transformers, right? The first one, so they now this is the first one, NP over NS equal to the ratio between VP and PS, right? So it can be written as in different way. Or as example, this can be written as VP over NP can be equal to VS over NS, right? So likewise, it can be written in or this equation can be written as a ratio between Vp over S equal MP over NS. So likewise, there are some certain ways that we can able to written this equation. Today, this is the first equation that you need to know regarding the transformers. The other thing is normally we consider the efficiency of a primary coil is equal to the efficiency of the secondary coil, right? So that means there's no energy loss. Hence, we can able to obtain an equation, right? First of all, you might familiar with this equation. Okay, this equation means this is power equal voltage into current, right? So according to the theoretical things, the power of the primary coil equal to the power of the secondary coil. Hence, we can able to obtain an equation as Vp into Ip can be equalized to the Vs into I is. That means the voltage of the primary coil into current flow in the primary coil equal to the voltage of the secondary coil into current flow in the secondary coil. So these are the two major equation which is used in the transformers, right? So you have to be familiar with these things. It's better to have idea because normally in the MCQ or in essay questions, there's a chance to ask this kind of equation, right? Okay, let's move on to the question. Now you can able to clear that at the X point, the voltage has increased. So then obviously in the X it should be a step up transformer, right? And uh, in the Y and the X, what happened to the voltage? The voltage is decreased. So that's mean obviously Y and X should be represented step down transformers, right? So these are the answer for the first one. Then in the second part, power station shown above is a thermal power station. Okay, there are some certain types of power station in which is used in Sri Lanka. The main is hydropower station. Secondary, we use a thermal power station, right? So, simple A, name a fuel used in a thermal power station. Okay, it can be coal, right? It can be coal or it can be diesel. These are the mostly used sources in a thermal power station. Right. B. You have to mention advantages and disadvantages of generating electricity by using thermal power station. Right. When we come to the advantage, okay, advantage of a thermal power station mean it can be generate electricity current, electric energy, generate electric energy to fulfill the consumption or generate electricity energy addition to hydropower, because normally in Sri Lanka we are basically depend on the hydropower station, but even though by using this kind of thermal power station it is additionally uh, we can able to generate some electric energy. So that's the advantages of having a thermal power station. And the disadvantages, there are some certain disadvantages of thermal power station. The first one is the major issue is environmental pollution, right? So that's the main issue. Environmental pollution, right? Okay. Then let's move on to the other question. Third part. Complete the following chart relevant to the production of electricity using thermal power station. Right. Okay, I think I can erase these equation except the above diagram, right? Because it is very useful when we describing the other question in the in the essay papers, right? So I think you have an idea about these stuffs, and if you have any doubts, please just put a comment, right? Right. So in every power station, um, the final output should be the electric energy. So um, in a thermal power station, now if I mention you a summary in a power station, to generate electricity, we have to rotate the turbines, right? That's mean rotating turbines mean it's obviously it's a kinetic energy, right? Rotating turbine, right? So to rotate these turbines or to create the kinetic energy, we use some several sources. The first one is thermal power station. So in a thermal power station, I mentioned that we are using coals or diesel. So on in these kind of uh, source, it is consist of the energy consists in a coal as a chemical energy, right? So when chemical energy by burning coal, this chemical energy convert into a thermal energy or heat energy, right? So by using this thermal energy, we rotate in the turbines. So that's the summary of this is the summary of energy conversion in a thermal power station. But if we come to a hydropower station, we mainly rotating the turbines by using the uh, potential energy of a waterfall, right? So this is the additional one. So actually, this is the answer for the third question, right? In a fourth part, you are asking um, non-renewable energy sources are used in thermal power stations, right? Name two renewable energy source used to generate electricity in power station of Sri Lanka, right? So it can be a wind energy or hydro energy. Hydro mean it is water, right? In the fifth one, name the component which connect firstly to the household circuit which belongs to the service provider, right? So I have drawn a simple diagram. This is the home electric circuit, right? This is the devices which is including in a home electric devices. So initially, this is the power supply, right? So it is first, it is go towards the overload circuits breaker, right? So let's consider this one as a supply wire. This supply wire is initially connected overload circuit breaker, and then we have electric meter. So then normally these two components are considered as is maintained by or regulated by the service provider. In service provider mean electricity board. That's the meaning of electricity board, right? So this is we considered as the service provider, right? So after that, then there's a wire connecting to the consumer box, right? Normally we call it or consumer unit, right? So these are the parts which is including consumer unit, right? First we have isolator, then the RCCB. RCCB means residual current circuit breaker, right? So then we move on to the MCB. MCB means miniature current breakers or miniature circuit breakers, right? So then from this MCB, we can able to distribute the current throughout the house, right? So the question is asking about the name the component which connect firstly to the current to the household circuit which belong to the service provider, right? It's obviously overload circuit breaker, right? So that's the answer for the fifth one. Overload circuit breaker, right? This is the answer for the fifth one, right? So let's move on to the other one. What is the component which disconnect when repairing the household circuit, right? So there is obviously isolated. You have to be very keen idea those stuffs, right? Because normally let's assume that you need to perform some kind of a repair in the household circuit. Then you have to disconnect the current flowing throughout the house, right? So that's why by using an isolator, we can able to disconnect the household circuits from the national grid or the main circuit, right? So the answer should be the isolator. Then in a transformer, if the number of turns in the primary coil is Np and the number of turns in the secondary coil is Ns and the voltage of primary coil is Vp and the voltage of the secondary coil is Vx, construct an equation to show the relationship between the above quantities, right? As I mentioned earlier, we can able to derive an equation uh, of these terms, that is the Vp over Vs equal to Np over Ns. This is the simple equation relevant with transformers, right? So in the next question, they have given some values in a transformer. If the number of turns in the primary coil is 8,000, and let's substitute the relevant values. Number of the secondary coil is 400. The voltage of the primary coil is 240, and you have to calculate the voltage of the secondary coil. Let's call it as Vs. So by simplifying these values, you can able to obtain a value for Vs, right? So these are easily simplified, isn't it? It should be 20. Then the answer should be the 12 volts. Right. So that's the end of the first question. So let's move on to the second question. Right. So in the second question, it is also basically focus on the home electric circuit, right? The diagram illustrates the connection of the main parts of the household circuit, right? Just familiar with this kind of circuit system, right? So in the ABCD, you have to name the ABCD component. Okay, in the A, it is illustrate the in the A that it is illustrate the overload circuit breaker. Right, this is the A, and B represent the electric meter. In the C circuit, in the C part, it is demonstrate the isolator. In the D, it should be RCCB. Right. So these are the four things that they are asking about the question on the questions, right? Then in the second part, write the functions of B, C, and D components separately. Right. Okay. Normally, B is the electric meter. The function of the electric meter is it is the device which is used to measure the B. The function of the B is it is used to measure the measuring consumed electric energy in household in industries, right? So it is by using this meter we can able to calculate the number of units which have consumed in the industries or in the households, right? So the C part. So we have in the C it is it is the isolator. So I mentioned earlier, isolator is it can be used to disconnect the disconnect the home circuit from the main grid. Disconnect the home whole circuit from the main grid or main power, right? So this is the function of the isolator, and then we have RCCB. So I mentioned you that RCCB is it is the device which is used to it is actually it's a kind of a safety purposes, right? So this RCCBs prevent or the protect residencies from electric shock. It is protect the residencies from electric shock. Just assume that whether if there's any current leakage in the house, if there's a current leak in the house, at once this the fuse which is inside this device is breakdown, and then there's no any further current flowing from this position, right? So it is basically used to as a protector devices, right? So this is the actual function of the RCCB, right? Okay. Then name the wire in the third part. Name the wire that is connected with fuse or circuit breakers. It's obvious. Now we have three types of wires: live, neutral, and the earth. Right? So live wire is directly connected with the fuse. Right. In the fourth one, write two special properties of the metal used in the fuses. Right. So they are now normally in a fuse. Let's assume that this is the current flow. Now it's mainly fuse is used to disconnect the circuit when there's a huge load of current flow towards the uh, house or towards this device, right? So then what is happened inside this fuse is, due to the high flow or high flow current, the metal inside the fuse is melted, right? Due to high flow current, this metallic part of the fuse metallic fast part of the fuse is melted, right? So then what happened? This circuit is disconnected. So when we come to the properties of this metal, the melting point of this metal part should be, it should be having a low melting point, right? Because when just increase the temperature, it's become the melting point and it is melted up, right? And this metallic part definitely having a high conductivity, because it should be, the current easily should be passed through these metals, right? So these are some of two factors, also two physical properties which should be consist of this metal which is used in a fuse, right? Okay, in the next question, what is the appliances used in modern circuits instead of fuses, right? Today it's obviously, nowadays we use MCBs instead of fuses, right? Because uh, this device is having a advanced technology rather than using a fuse. Then, so in the B question, so this is the answer for the A part of the second question, right? So let's move on to the second. Uh, let's move on to the B part, right? In the B section, certain plugs are connected with 3 core wires, right? What are the 3 wires in 3 core wires, right? Here, they are asking about the live wire, neutral wire, and the earth wire. They are asking about that. Then mention suitable wires for A, B, C. Right. Okay, let's consider whether this is a switch. And in a normally switch consists of 3 pins. The above pin is obviously the earth wire, right? So the upper one should be the earth. This one can be, if it is live wire, then this should be the neutral wire. So this is the normal position of the wires in a plug point. So in the C part, after settling a new house, Isuru bought an electric motor. In the motor, it was indicated voltage is equal to 230 volt and I is equal to 8 amperes. Right. This motor is displayed that V is 230 volt, I as 8 amperes. Right. These are considered as the rating of a electrical device. That means to function in an optimum way, these are the condition or these are the requirement that should be fulfilled, right? Then, in the first question, write down all the energy conversions taken place in a motor. Then, in a motor, the main energy conversion should be the electric energy convert into kinetic energy. This is the main energy conversion in a motor. Even though electric energy can be converted into thermal energy. So when the motor is functioning, there must be the temperature of in the motor can be increased. It is due to heating up. So that means there's a thermal energy productions also. And as well, there might be some kind of sound when functioning a particular motor, and the electric energy can be converted into sound energy too, right? So these are the energy conversions which is happen in the motor, right? Then find the power of the motor. In your paper, it is written as efficiency, but it is not the efficiency. We have to find the power of the motor, right? So how should we obtain the power? You already know that that's the equation which is I mentioned earlier. Power equal to voltage into current, right? So if I substitute the relevant values for this equation, voltage should be 230, I should be 8. So then the answer is 180, 1840 watt. Keep in mind that the unit of the power is watt, right? So in the third question, if the motor works 15 minutes a day, find the electric energy spent a day, right? Now, we have written an equation relevant with power now. There are some certain, there's a common equation for power. Power means normally we consider energy over time. Right. Now, if you are asking about the energy, it's better to subject the energy. So, if it is subjected, energy equal to power into time. Right. Here, power is equal to 1840. Time, it is mentioned at the 15 seconds. Right. 15 minutes. So keep in mind that when you substitute in the particular values for this equation, time should be allocated in seconds. So they have given the 15 minutes. So when we convert minutes into seconds, we have to multiply it from 60, right? So the answer should be given in joule. So if I calculate the answer, it should be it's up to you, right? Right. So this is the energy, electric energy, which is generated in this motor. Right. In the fourth one, therefore find the number of units in an electricity bill due to usage of motor. Right. So normally in an electricity bills, uh, the electric energy is given as a unit. One unit is equal to 1 unit is equal to 1 kilowatt hour, right? So when you write down the kilowatt hour, K should be simple, W should be capital, and H should be simple, right? So how should we convert this energy into a kilowatt hour? It's very easy. Now we already have obtained the power of this motor, right? So then let's substitute it. If the power is 140 watt and it is used 15 minutes per day, right? So then could they keep in mind that when you substitute in the uh, time into this equation or into this expression, it should be converted into hours, right? Because 1 unit is equal to kilowatt hour, right? So then now we have already converted the particular units, but there's a small issue that we need to perform it. The normally what should be given as a kilowatt. So then, in order to convert this watt value into kilowatt, what should we do is we have to divide it from 1000. Then this can be considered as kilowatt, right? So this is the uh, this is considered this can be considered as a unit. So the if I simplify it, we can able to obtain that this is the number of units which is used from this electric motor, right? Okay, I think you have obtained some kind of knowledge regarding those stuffs, right? Especially the you have to familiar with this equation, right? Okay. So shall we move on to the next question? Okay. In the third question, the same question is asking about the home electric circuit, right? Electric energy produced in Sri Lanka national grid is converted into different forms. Effect of electricity are used to fulfill our energy needs and in communications. Right. A part of a national grid is shown below. Right. So they just go through the diagram. Name the service via A and B. Right. So in this instant, in this diagram, in the first part, A wire mean is obviously it is the live wire, and B mean it is the neutral wire. Right? A is the live wire and B is the neutral wire. Then in the second part, what is the potential difference of the domestic supply? It should be 230 volts, right? What type of current? What type of current? Normally, electric current can be divided into two parts: direct current, and it is and also there's a alternative current. Now, in national grid, we obtain current as the alternative current. We normally defined as AC current, right? So in the third one, what is the frequency of electric current? Now these are some numerical values. In Sri Lanka, we obtain a frequency of with 50 hertz, right? So answer is the 50. Identify the relevant wires to which Q and R should be connected, right? So in this plug point, the upper one should be obviously connected with the earth wire. right? So this should be connected with the earth wire, and the other two should be connected with the neutral and the live wire. Right. In the third part of this question, observe the label of the electric cooker and write the answer. Right. They have given that the rating of this electric cooker, that is 1500 watt and 230 volts. First one, what do you understand by 1500 watt? Okay, 100 and 500 watt mean the energy which is generate in 1 second is equal to 1500 joule. Now this 1500 watt mean the energy of 1500 joule energy is consumed in 1 second. That's the meaning of this watt, right? Normally, we use joules per second instead of watt, right? So likewise, 1500 watt mean the energy 1500 joule energy is produced in 1 second or unit time. 1 second can be expressed as a unit time, right? Right. Then when this electric cooker is completely in function, find out the current flow through the heating coil. Right. So now we already have know this equation. If I substitute, this should be this one. Right. Then I can be obtained by dividing this value from, right. So if I simplify it, I can able to obtain that answer as the 6.5. If it is current, so the unit should be amperes, right? Okay. Now in the next part, that means the fourth part, it's a very good question, right? Normally it can be expected in a exam, right? So let's go through the question. 800 water at 30 degrees is taken in a thin light aluminium vessel is placed on a given electric cooker which covers the cooker completely and electric current is supplied to the cooker. Right. So in this aluminium vessel, it is consist of 0.8 kilograms of water which is at 30 degrees. Right. Then what happened? What write the advantages by flatten bottom of the aluminium vessel? Like normally every vessel having a flat bottom, right? So when we kept this vessel on a cooker or on a hot plate, the importance of having a flat bottom is then this vessel can be absorb heat energy efficiently, can be absorbed heat energy efficiently, right? So this is the importance of having a flat shaped bottom, right? In the B, which property of aluminium is responsible for its low heat capacity? It should be specific heat capacity. That's mean the required, so let's assume that if a particular substance having a low specific heat capacity, that's mean to increase the temperature from 1 Celsius, the required energy is very less, right? That's the meaning of the low heat capacity, right? So I'm erasing this part. Now let's assume that in water normally the specific heat capacity having a 4200, and in aluminium let's call it as, so you need to be very familiar with this unit of this specific heat capacity, right? So this can be considered as a Kelvin or Celsius, right? That means to increase the temperature in 1 degrees in a water, it is required 4200 joules. But even though in aluminium vessel, the required energy to increase the one temperature Celsius is 400 joule, right? So that's the importance of having a low specific heat capacity, right? See, if the heat capacity of the aluminium vessel is less, what can you say about the time taken to water to reach the boiling point, right? So that's mean if they are saying if the vessel having a low specific heat capacity, that's mean that the temperature is getting increased with a minimum heat energy. That's mean the vessel obtain the boiling point with the limited time. So that's mean the time is getting decreased, right? The vessel is quickly reach the boiling point. That's the so that should be the answer. The time is getting decreased, right? The C part, write the time taken in second which is needed the water to reach the boiling point, right? Okay, this one is a good calculation, right? So now so according to the question, this water is consists of 0.8 kilogram mass, and initially it is in the 30 degrees, right? Now when a boiling mean the temperature should be increased up to 100. So this means the temperature of this water should be increased from 30 to 100 to obtain the boiling point, right? So normally we use Q equal mc theta to obtain the heat absorption or heat emission when there's a temperature difference, right? So here the temperature is increased from 30 to 100. Then for that purposes, let's find out what is amount of heat energy absorbed by this water. M is 0.8, right? C means the specific heat capacity of the water. It should be 4200. Then theta. So theta means temperature difference. Now initial temperature is 30 and it should be increased up to 100. So that's mean the temperature difference is 70, right? So if you calculate this one, then you can able to obtain that this is as the answer, right? However, we are asking about the time which is taken to reach the boiling point, right? So now we have obtained that the energy required to or energy required to increase the temperature from 30 to 100, right? So by now we already know the power of this but of this electric kettle, electric cooker, right? Then previously I mentioned that power is equal to energy over time, right? Then if I substitute this value, P mean 1500. We already have obtained that. That is, this is the value of the energy. So let's assume with time as t. Then by dividing these values, we can be able to obtain the time which is taken by the water to increase up to the 100 Celsius. So if I simplify it, we can able to obtain that the answer as the 156 seconds. So this is the it is a one of the best calculation that can be expected at the exam, right? Okay, so let's move on to the final question. So in the fourth question, the diagram given below shows a setup prepared by your students to study about the behavior of electric current. The resistance of AD conductor is 90 ohm and the potential difference is 3 volt kilo. Right. So here this is the AD wire. And the resistance of this part is 90 ohm. Right. First question. The terminal E touch the point B, C, and D from A. How the brightness of the bulb changes, right? So just concern this one. Now there's a bulb here. Right. So let's get this pointer at this point. So then you should have to you should know that the current is flowing from this limited direction, the circuit, right? So let's assume that if the pointer is reached up to this point, then current have to flow this much of distance, right? Right. So here you should be know that today resistance is proportionate to the length of a wire. That's mean when the length of the wire is increased, resistance also is increased. Right? On the other hand, resistance is inversely proportionate to the area. Inversely proportionate means when the area is increased, what happened to the resistance? It is decreased. So keep in mind those stuffs, right? Okay. So let's come to the question. So when now this is this this wire having a resistance, right? So when this pointer moved away from the A, the distance is getting increased. So let's assume this is the distance at the initial point, and this is the distance in the next point. So then obviously length of the wire has increased when the pointer moved from A to D, right? So as a result, what happened to the resistance? As I mentioned earlier, when the length of the wire increase, obviously resistance is also increased, right? So when the resistance is increased in a particular circuit, what happened to the current flow? Current flow should be reduced. Current flow should be decreased, right? So as a result, what happened to the brightness of the bulb when the so what happened to the brightness of the bulb? It is also getting is reduced. So that's the answer for the central A. Right. In the B part, they're asking about what is the reason for above answer. So they're asking about the what is the reason for reducing the brightness, right? So this is the answer for the second one. When the length of the wire increase, resistance of the wire increase. As a result, current flow getting reduced. That's why the brightness is getting decreased. So this is the answer for the A, and this is the answer for the B. Even I written in the above, this is the correct answer for the B part, right? Okay, let's move on to the second part of this question. The conducting wire ADR. So I will erase the right. So this one is also is a good question, right? So now previously we have a wire labeled as AD. Now this wire having a 90 ohm resistance. Now according to the question, the conducting wire AD is cut into two equal parts, right? So when it is cut to equal parts, the resistance also is divided into two. That means the resistance of this part should be 45 ohm. Resistance of the other part should be also 45. Then what we do is we connected these two wires in parallel way. Right? We connecting these wires in parallel way. So then you are asked to obtain the equivalent resistance of this wire, right? So now Bhute, you know that how to obtain the equivalent resistance in a parallel resistor system, right? So let's assume that the equivalent resistance as R, and this one having a 45 ohm, this also having a 45 ohm. So according to the equation that we learned, 1 over R equal to 1 over 45 plus 1 over 45. Right. So the denominators are common. So then we can able to add the denominators each other. Then R equal 45 over 2. Then the answer should be the 22.5 ohm. So this is the equivalent resistance. Right. In the next part, so today this is asking about the deflection of a galvanometer when there's a electromagnetic induction, right? State the deflection of center zero galvanometer in above instances at the time of closing the switch. Today I already mentioned you in the previous paper. When we switch off the galvanometer, there's a deflection of the galvanometer. There's a deflection of the galvanometer, right? When switch is closed, now this switch is already closed. That means there's no any deflection of the galvanometer when opening the switch. I previously mentioned that in the previous paper, the galvanometer only detecting a deflection when switch on and switch off. So that's mean there's also deflection in the indicator, right? Okay, so that's the discussion for the paper, test paper 4, right? So if you have any doubts or any kind of issues, just leave me a message in the comment section, right? So then let's meet in another session related with science in the ordinary levels, right? So then good luck. Have a great day.